Welcome to mathematics class, bridge course, first PU. Already we discussed so many things in the previous classes. We shall record the formulas, the basic algebraic identities once again. Those who missed the class, those who joined late. Starting from a plus b the whole square. A plus b the whole square is equal to a square plus b square plus 2ab. Very basic algebraic identity it is. Already learned in high school, just I am refreshing it once again. Second one, you can make a guess, which I am going to write. A minus b the whole square. This is equal to a square plus b square minus 2ab. Third one, a plus b the whole square plus a minus b the whole square. Add these two. Adding these two left hand sides, we get this. And the right hand side also, a square plus a square, 2a square, b square plus b square is 2b square. 2ab is of opposite side, cancels out. So what we get is 2 times a square plus b square. Learn this, useful even in trigonometry. These kind of formulas, a plus b the whole square plus a minus b the whole square is 2 times a square plus b square. We may require even vectors. You are going to study vectors, complex numbers. You require this kind of identity in those chapters. Okay. Next, we are going to discuss the subtraction of these two. A plus b the whole square minus a minus b the whole square. Subtract these two. A square cancels. B square cancels, 2ab minus of minus 2ab, 2ab plus 2ab is 4ab. A square minus a square 0, b square minus b square 0, 2ab minus of minus 2ab, 2ab plus 2ab becomes 4ab. Next we got difference of two squares. A square minus b square is equal to a plus b into a minus b, correct? It's called as difference of two squares. A square minus b square equal to, can decompose into two factors. The first factor is a plus b, second factor is a minus b, or a minus b into a plus b, both one and the same. Next we can discuss a cube minus b cube is equal to a minus b into a square plus ab plus b square. A cube minus b is called as difference of two cubes. Difference of two cubes. A cube minus b cube. A minus b into a square plus ab plus b square. Seventh one we have sum of the two cubes. A cube plus b cube. Sum of the two cubes can be decomposed into a plus b into a square minus ab plus b square. Sum of the two cubes, a plus b into a square minus ab plus b square. Please write all these formulas. Make it a habit of writing all the formulas daily once. Basic algebraic identities. 8th one, a plus b plus c the whole square. This is a square plus b square plus c square plus 2 times ab plus bc plus ca. A plus b plus c the whole square is a square plus b square plus c square plus 2 times ab plus bc plus c. Next one we have a plus b the whole cube. Can you write this? Can you fill this? A minus b the whole cube. Next one is x plus a into x plus b. A plus b the whole cube. What is the identity for this? A plus b the whole cube. A cube plus b cube. A cube plus b cube plus 3ab into a plus b. From this a cube plus b cube can be extracted. Already we have one formula for a cube plus b cube, correct? This is product of two factors. Further I can write a cube plus b cube as a plus b the whole cube minus 3ab into a plus b. Another way of writing a cube plus b cube. Another formula for a cube plus b cube is a plus b the whole cube minus 3ab into a plus b. Okay, a minus b the whole cube is a cube minus b cube minus 3ab into a minus b. A cube minus b cube is a minus b the whole cube plus 3ab into a minus b. Another formula for a cube minus b cube. X plus a into x plus b. X into x, x square plus x into a plus b plus ab. Multiply this and take x common, you get this. X plus a into x plus b is x square plus x into a plus b plus ab. Multiply term by term. X into x, x square plus ax plus bx plus ab. X is common. Ax plus bx. X is common. X times a plus b plus ab. Note down all these formulas. Make it a habit of writing all the formulas daily once. Also given the trigonometry formulas. These are the basic algebraic formulas which already learned in high school level, but it's required even in PUC. So I have written all these formulas. Next, write trigonometry formulas. Sine of x plus y. Trigonometry formulas. These are called as compound angle formulas. We got compound angle formulas, multiple angle formulas, submultiple angle formula, transformation formula, various types. Sine of x plus y is sin x into cos y plus cos x into sin y. Sin of x minus y is equal to sin x into cos y minus cos x into sin y. Next we have cos of x plus y. Cos of x plus y is cos x cos y minus sin x into sin y. Cos of x minus y is cos x into cos y plus sin x into sin y. These are called compound angle formulas. Write along with me, maintain separate notes for each subject. Tan of x plus y is tan of x plus y is, you know all the 6 trigonometric functions, right? These are called compound angle formula. Sum, difference, sum, correct, difference, sum. Tan of x plus y is tan x plus tan y divided by 1 minus tan x into tan y. Next we have tan of x minus y. Tan of x minus y is tan of x minus y is equal to, can make a guess for this? Tan of x minus y is equal to tan x minus tan y divided by 1 plus tan x into tan y. Next we have tan of pi by 4 plus x. Tan of pi by 4 plus x equal to 1 plus tan x by 1 minus tan x. Tan of pi by 4 minus x. Tan of pi by 4 minus x is 1 minus tan x divided by 1 plus tan x. Pi by 4 is 45 degree, okay, remember pi by 4 is pi by 4 radians. I'll introduce that later, radians, when we come to first year offline classes. For time being, just learn this pi by 4. Pi by 4 means it is equal to 45 degree. Pi radians is 180, pi by 4 is 45 degree. Tan of pi by 4 plus x. Tan of pi by 4 minus x. Next we have cot of x plus y, cot of x plus y is cot x cot y minus 1 divided by cot y plus cot x. Next one, cot of x minus y is cot x cot y plus 1 divided by cot y minus cot x. Next we have the multiple angle formulas, sin 2x, cos 2x, tan 2x. Sin 2x is equal to 2 sin x cos x is also equal to 2 tan x divided by 1 plus tan square x. These are called multiple angle formulas. Sin 2x, the two formulas for this. 2 sin x cos x is also equal to 2 tan x by 1 plus tan square x. Next we have cos 2x. Cos 2x is cos square x minus sin square x is equal to 2 cos square x minus 1 is also equal to 1 minus 2 sin square x is also equal to 1 minus tan square x divided by 1 plus tan square x. Tan 2x is equal to 2 tan x divided by 1 minus tan square x. Next we have sin 3x. Sin 3x is equal to 3 sin x minus 4 sin cube x. Cos 3x is equal to 4 cos cube x minus 3 cos x. Tan 3x is equal to 3 tan x minus tan cube x divided by 1 minus 3 tan square x. Turn on these formulas properly. These are called multiple angle formulas. This set sin 2x, cos 2x, tan 2x, sin 3x, cos 3x, tan 3x. These are called multiple angle formula. Also, we have submultiple angle formula, also called half angle formula. You replace x by 2, it becomes sin x. That's called half angle formula. Okay. For time being, for today, this much you learn formulas. I'll write half angle formulas and transformation formulas later. We'll move on to the focus on analytical geometry. Okay, analytical geometry is applying the algebra to geometry. Applying algebra to geometry is called as analytical geometry. Okay, what is studied in high school is only the solid geometry. CBSE students have learnt the distance formula, section formula. That comes under the topic called analytical geometry. Applying algebra to geometry is called as analytical geometry. It's a separate branch of mathematics where we are applying algebra to geometry. Okay. To study triangles, circles, that is called solid geometry. Solid geometry. Okay. Here you find the equations of circles. You find the equation of a straight line. Correct. All these things will be discussed. Or different curves we are going to discuss. Not only circles, parabola, ellipse, hyperbola, all those things. Different curves we are going to study. Finding the equations of those. Finding the tangent to those. Drawing normals and finding the equations of normal to those curves. All those things will be dealt in this. So the two real number lines taken which are mutually perpendicular to each other, okay, x dash ox and y dash oy. x dash OX, y dash OY. Divides the plane into 4 quadrants as we discussed earlier also. This is called as the first quadrant, this is called as second quadrant, this is third quadrant, and this is fourth quadrant. First quadrant, both x and y are positive, both x and y are positive, correct? First quadrant, both x and y are positive. Second quadrant, x is negative, y is positive. Third quadrant, both x and y are negative. Fourth quadrant, x is positive, y is negative, correct? Fourth quadrant, x is positive, y is negative. You must know this. And we discussed about trigonometry functions also, signs of trigonometry functions in various quadrants. But remember, first quadrant, both x and y are positive. Second quadrant, x is negative, y is positive. Third quadrant, both are negative. Fourth quadrant, x is positive, y is negative. Also, we got to study 3-dimensional geometry where we have 8 octants. Okay, there are 4 quadrants: the x-axis and y-axis. X dash OX is called as x-axis. Y dash OY is called as y-axis. They are mutually perpendicular. They meet at a common point. Is called as origin O. Meet at a common point. This is called as origin. In this we have various formulas. Can you recall some of the important formulas? Distance formula. Distance formula is to find the distance between the 2 points, correct? If you have 2 points A and B, A is x1 comma y1 and B is x2 comma y2. AB is distance between the 2 points given by a distance formula, root of x2 minus x1b whole square plus y2 minus y1b whole square. It's called as distance formula. Already you studied this distance formula in 10th standard already, correct? And also we can find the distance of the point from origin. Distance d. D is the distance of the point x comma y from origin. D is the distance. D is the distance of the point P x comma y from the origin. From the origin. Then d is the origin is 0 comma 0. Then d is given by root of x square plus y square. D is the distance of the point P x comma y from the origin. Then d is root of x square plus y square. Okay. Learn this distance of the point from the origin. Origin is 0 comma 0. The point of intersection of the x-axis and y-axis is called as the origin. Origin is denoted with symbol O. O is a symbol for origin. 0 comma 0. D is equal to root of x square plus y square. D is the distance of the point from the origin. D is root of x square plus y square. What are the applications of distance formula? I will learn the applications of distance formula. One is the 3 points are lying on the same line. Suppose you take A, B, C lying on the same line. If 3 points lie on the same line, what do you call them? They are collinear. Have you heard the word collinear, students? 3 points are said to be collinear if they lie on the same line. Collinearness. Collinearness. Collinear means A, B, C lying on the same line. 3 points A, B, C are collinear if they lie on the same line. A, B, C lying on the same line. 3 points lying on the same line. Here using distance formula, we can prove that the 3 points are collinear. AB plus BC is equal to AC. That is AB plus BC. Sum of the these two is equal to third. AB plus BC is equal to AC. Sum of the least two is equal to third. AB plus BC. AB plus BC equal to AC. This is how we prove 3 points are collinear using distance formula. Okay, 3 points are collinear if sum of the least two is equal to third. Okay, AB plus BC equal to AC. Collinear means 3 points are collinear means sum of the least two is equal to third. Next we can discuss parallelogram and triangle, various types of parallelogram. Have you heard the various types of parallelogram? Also various types of triangle. This is about the collinearity of 3 points. Next we can discuss about the triangle, equilateral triangle. ABC is said to be an equilateral triangle if all the sides are equal. Triangle ABC is equilateral. Triangle ABC is equilateral implies implies the sides are equal. AB equal to BC equal to CA, correct? Triangle ABC is equilateral. AB is equal to BC is equal to CA. All the sides are equal. Using distance formula we can prove all the sides are equal. Triangle ABC is equilateral. Triangle ABC is isosceles. Isosceles. Any two sides are equal. Any two sides are equal. AB equal to BC. AB is equal to BC. Then we say triangle is isosceles. AB equal to AC in this case, not BC. AB equal to AC. Triangle is isosceles. Any two sides are equal. Okay. In this case, the angle opposite to side AB, this angle becomes 45. This is also 45. Okay. Angles opposite to the sides are also equal. This will be equal to 45, 45. Maybe I'm telling. If it is isosceles right angle triangle, otherwise simply if it is isosceles we cannot tell. If it is isosceles right angle triangle, I can tell two of the angles will be equal to 45 degree and one angle is 90 degree. If it is an isosceles right angle triangle. Now it is just an isosceles triangle, so I can tell two sides are equal and two angles are equal, opposite to this and opposite to this. Next we can have different types of parallelograms. In a parallelogram the opposite sides are equal and parallel, you must know this. In a parallelogram opposite sides are equal and parallel. ABCD is a parallelogram, opposite sides are equal. Opposite sides are equal and they are parallel. These two are equal. AB is equal to DC and BC is equal to AD. Okay, length of the sides are equal. AB is equal to DC, BC is equal to AD. Length of the sides are equal. Opposite sides are equal. And also we have the property that the diagonals bisect each other. Length of the diagonals are not equal, but diagonals bisect each other in this case. So I can call this point as E. E is the midpoint of AC. E is also the midpoint of BD. Diagonals bisect each other. The properties of the parallelogram you must know, students. Okay. The distance, the opposite sides are equal. AB is equal to DC. BC is equal to AD. Opposite sides are equal. Opposite sides are parallel and equal, right? Next one. and also diagonals bisect each other. That means midpoint of AC same as midpoint of BD. Diagonals bisect each other. That means midpoint of AC is same as midpoint of BD. You can note all this. Midpoint of the diagonals coincides. Midpoint of AC is equal to midpoint of BD. Midpoint of AC equal to midpoint of BD. Next we can discuss about square. In a square all the sides are equal. All the sides are equal. You know this. All the sides are equal. Each corner angle is 90 degree. I am discussing the properties of various parallelograms. We can prove if the four vertices are given to you, we can prove those vertices form the parallelogram, rectangle, square, all those things. Okay. So ABCD is a square, means all the sides are equal. All the sides are equal. And the diagonals are also equal. Diagonals are equal. ABCD. ABCD is a square, means all the sides are equal. Diagonals are equal. Diagonals are also equal. Correct? You must remember this. Length of the diagonals are equal. Square is a particular type of the parallelogram where all the sides are equal. Correct? Opposite sides are parallel only. All the sides are equal and length of the diagonals are also equal. All the sides are equal. All the sides are equal in case of a square. That is AB is equal to BC is equal to CD is equal to AD. All the sides are equal. Okay. Further, diagonals are equal. Diagonals. Diagonals are equal. That is AC is equal to BD. And also we can have the relationship between the sides of the square and the diagonal. Diagonal of the square. This is the diagonal of the square. That is root 2 times the side. You can apply the Pythagoras theorem because each of the corner angle is 90, right? Each of this corner angle is 90. This angle is 90, correct? AC represents the diagonal, no? Diagonal. Diagonal square is equal to AB square plus BC square. AB you take it as A. Let the side be equal to A. All the sides are equal to A, correct? In that case, D square, length of the diagonal square is A square plus A square. A square plus A square. A square plus A square is 2A square. D square is 2A square. So D is root 2A. D is equal to root 2A. Relationship between the diagonal of the square and the side of the square is root 2A. Diagonal is root 2 times the side of the square. Relationship between the diagonal and the length of the side of the square. Next we can discuss about rectangle. Rectangle. ABCD is a rectangle. Opposite sides are equal and parallel in a rectangle. Opposite sides are equal and parallel. Is the midpoint of the diagonals. Here also diagonals bisect each other. In any parallelogram, diagonals bisect each other. Opposite sides are equal. Opposite sides are equal and the diagonals, length of the diagonals are equal. Length of the diagonals are equal. This is equal to this. This is equal to this. Correct? AB is equal to CD. AD is equal to BC. Length of the diagonals. Length of the diagonals are also equal. AC is equal to BD. AC is equal to BD. Okay, this is rectangle. Next is we have rhombus. Here also we can have the relationship between the diagonal of the square and the sides of the rectangle. The diagonal of the rectangle and the sides of the rectangle. We take x as a side, y as another side. Adjacent sides are x and y. Diagonal is b. Okay, b is the length of the diagonal. Then we have b square is equal to x square plus y square. Or length of the diagonal is root of x square plus y square. Length of the diagonal is root of x square plus y square. Next we have a rhombus. ABCD is a rhombus. ABCD is a rhombus. Rhombus is a particular type of the parallelogram where all the sides are equal. Okay, all the sides are equal. All the sides are equal. Diagonals bisect each other. In any case, any parallelogram diagonals bisect each other. Length of the diagonals are not equal here. Length of the diagonals are not equal. In a square, what's the difference between the square and the rhombus? In a square, all the sides are equal. In a rhombus also, all the sides are equal. Okay? In a square, diagonals are equal. In rhombus, diagonals are not equal. Length of the diagonals are not equal. Okay, it's a rhombus where AB is equal to BC is equal to CD is equal to BA. All the sides are equal. Okay. Further, we have the diagonals length B1 is not equal to B2. Length of the diagonals are not equal. B1 and B2 are the diagonals. B1 is not equal to B2. B1 is not equal to length of the diagonals are not equal. Area of the square we know, area of the rectangle we know, correct? How to find area of the square? Area of the square is A is equal to A square. Area is equal to A square, side square. Here how to find area of the rectangle? Area of the rectangle is length into breadth. Here area of the rectangle is half into product of the diagonals. Half into product of the diagonals. B1 into B2. So note down all these things. Various figures are done. Parallelogram, rectangle, square, rhombus. Also we have a trapezium. We can discuss about the trapezium. This This is called trapezium. A, B, C, D, E. It's called trapezium, where exactly one pair of opposite sides are equal. Okay, A, B, C, D is a trapezium. Area of the trapezium is half into. To find the area of the trapezium, we can do like this also. To find the area of this rectangle plus area of the triangle. Area of the rectangle plus area of the triangle, that gives area of the trapezium. Area of the trapezium can also be given as half into sum of the parallel sides into perpendicular distance. Which are the parallel sides here? AB and CD are the parallel sides. AB plus CD, sum of the parallel sides into the perpendicular distance, that is C. C is the perpendicular distance. Now done this, find area of the trapezium. So all these things you note down, students. They can prove the given vertices are going to be a square or rectangle or rhombus or trapezium, all those things. Using distance formula you can find all those things. So, parallelogram can be different types of parallelograms are there. Parallelogram itself is one piece I can discuss. Second one is wave. Third one is rectangle. Fourth one is rhombus. Parallelogram, opposite sides are equal. Opposite sides are equal and parallel. Equal and parallel. Opposite sides are equal and parallel. Okay. Diagonals bisect each other. Diagonals bisect each other. That means midpoint of the diagonals coincide. Midpoint of AC equal to midpoint of BD. Diagonals bisect each other. In a square, all the sides are equal. All the sides are equal. Further, opposite diagonals are equal. Diagonals are equal. Opposite sides are equal and parallel. Diagonals bisect each other. It is of parallelogram. If you want to find the area of the parallelogram, it is base into height. Area of the parallelogram is base into height. Area of the square is side square. Area of the side square is side square. A square you can call. In rectangle, opposite sides are equal. Opposite sides are equal and parallel, that is same. And diagonals are unequal. Here diagonals are unequal in parallelogram. Length of the diagonals are not equal. Diagonals bisect each other. Diagonals bisect each other. Whereas here diagonals are equal. Diagonals are equal. Area of the rectangle is x into y, where x is the length and y is the breadth. In rhombus, all the sides are equal. All the sides are equal. Diagonals are unequal. Diagonals are unequal. Area of the rhombus is half into product of the diagonals. Half into d1 into d2. Area of the rhombus is half d1 d2. Half into product of the diagonals. Trapezium, opposite sides, one pair of opposite sides are equal. Not both the pairs, one pair. One pair of opposite sides is equal. And the area of the trapezium is half into sum of the parallel sides. Sum of the parallel sides multiplied by the perpendicular distance. Half into sum of the parallel sides into perpendicular distance. So these are the important properties of the various types of the parallelogram. Using the distance formula, we can prove the given vertices whether it forms rectangle, rhombus, correct, square, trapezium, and parallelogram. Different types of quadrilateral, I can tell. These are different types of quadrilateral. Next, we can discuss section formula. For internal division, the point P divides AB, point P x comma y divides AB. Internally in the ratio m is to n. Point P divides AB. Internally in the ratio m is to n. Internally in the ratio m is to n. Where A is given by the coordinates of A is x1, y1. Coordinates of B is x2, y1. Cross multiply this, crisscross, multiply this. To get that coordinates of the point P x, y is equal to m into x2 plus n into x1. M into x2 plus n into x1 divided by m plus n. M into y2 plus n into y1 divided by m plus n. Crisscross, multiply. M into x2 plus n into x1 by m plus n. M into y2 plus n into y1 by m plus n. Point P divides AB. Internally the ratio m is to n. In the coordinates the point P is given with this for internal division. Further we can discuss section formula for external division. The point P divides AB externally the ratio m is to n. In that case, for external division, P divides AB externally. P divides AB externally in the ratio m is to n. Okay, in that case, Px, y is equal to m into x2 minus n into x1 by m minus n. m into y2 minus n into y1 divided by m minus n. In this case, for x rotation, point P is outside AB. Point P is outside AB. Further, we discuss the centroid of the triangle. What is centroid? Do you know? Centroid is the point of intersection of the medians of the triangle. What is centroid? Centroid is the point of intersection of the medians of a triangle. If you want to find the point of intersection of the medians, what do you mean by median? Median is the line segment joining the vertex. Median is a line segment joining the vertex to the midpoint of the opposite side. To the midpoint of the opposite side. Median is the line segment joining the vertex to the midpoint of the opposite side. D is the midpoint, AD is the median, D is the midpoint of the BC. D is the midpoint of BC. BE is the median, E is the midpoint of AC. CF is the median, F is the midpoint of AB. There are three medians for a triangle. The point of intersection of the medians is called as the centroid. Centroid is denoted by the symbol G. G is the notation for centroid. The point of intersection of the medians of the triangle. G is the point of intersection. G is the point of intersection. Point of intersection of the medians of the triangle. Point of intersection of the medians of the triangle. Median is the line segment joining the vertex to the midpoint of the opposite side. You must know what is the definition of the median. We can find the equation of median in a chapter called straight lines. ICSE students might have studied straight lines already. Okay. AD is the median, DE is the median, CF is median. There are three medians for a triangle. The point of intersection of the medians is called as centroid. Centroid is usually denoted by the symbol G. G stands for centroid of the triangle. Also know that the centroid of a triangle divides the median in turn in the ratio 2:1. Centroid divides the median, centroid G divides the median in turn in the ratio 2:1. 2 is towards the vertex side, 1 is towards the opposite side. Okay, must know this. Centroid divides the median in turn in the ratio 2:1. Using section formula, we can find the coordinates of the centroid. Okay, coordinates of centroid is given by G. X comma y is equal to x1 plus x2 plus x3 divided by 3, y1 plus y2 plus y3 by 3. Also we have the midpoint formula. I forgot to discuss about the midpoint formula. Here I can tell midpoint. If the point P divides AB in turn in the ratio 1:1, then the point P x comma y is x1 plus x2 by 2, y1 plus y2 by 2. x1 plus x2 by 2, y1 plus y2 by 2. P x comma y is x1 plus x2 by 2, y1 plus y2 by 2. P is the midpoint. P is the midpoint of AB. P is the midpoint of AB. x1 plus x2 by 2, y1 plus y2 by 2. P is the midpoint of AB. G is the centroid. Centroid of the triangle is x1 plus x2 plus x3 by 2, y1 plus y2 plus y3 by 2. Take the vertices as x1 comma y1, x2 comma y2, x3 comma y3, Further we can discuss area of triangle, and also there are three more notations, important notations. Not only we have centroid, G is a centroid. Similar to centroid, we have the orthocenter, circumcenter and incenter. Also we can relate those three. We can relate centroid, orthocenter and circumcenter. Okay, various things to be noted in this case. Centroid of the triangle is given by this, note of this formula, and this is a midpoint formula. The point P divides AB, in turn the ratio 1:1. The point P is equidistant between from the 2 points A and B. AP is equal to BP. AP is equal to BP. Okay. So centroid is given this x1 plus x2 plus x3 by 2, y1 plus y2 plus y3 by 2. Centroid is given this. Centroid G divides the median, in turn the ratio 2:1. Also, if you take a triangle, like this triangle is there, any triangle ABC, G is the interior point of the triangle, this is the centroid. Okay. In that case, what happens is you join this centroid to each of these vertices. In that case, we can have area of triangle GAB is equal to area of triangle GBC equal to area of triangle GAC. All the three areas are equal. Okay. If you take sum of these three areas, we get area of the triangle ABC. Area of triangle ABC is, we can have a relationship. Area of the triangle ABC is 3 times area of the triangle GAB. 3 times area of the triangle GAB. Okay, it's also equal to 3 times area of the triangle GBC or area of the triangle GAC. 3 times area of triangle GAC. Area of triangle ABC equal to 3 times area of the triangle GAB, GBC, GAC. One more last point to note down. Area of each of these triangles are equal. Area of triangle GAB is equal to area of triangle GBC is equal to area of triangle GAC. All the areas are equal. All the areas are equal. So we'll wind up for today. We'll continue tomorrow next class. Okay. Discuss various properties of different types of parallelogram. Also different types of triangle, distance formula, section formula, centroid of the triangle. Also we have the formula for area of triangle, which you know already learned in 10th standard. Half into x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. We can express in terms of determinant also. We'll introduce the concept of determinant later when we come to PU. Okay. Area of triangle can also be expressed in terms of determinants. Okay. So note down all these things. Go through it once again. Write the trigonometry formulas every day once. Put the dates and write every day algebraic identities as well as trigonometric formulas. Okay. Thank you.
Can